That's it. Yeah. Start with energy. Okay. Tablet has no out of battery. So what are we doing is just waiting for the tablet while we are preparing for other topics. There's this paper I want to read. We always have another thing to do. So much light in my face. All snowy outside and the reflection. Let me close the curtain. Go! One. Two. It's actually 5th floor and still I get a lot of light. Okay. Doubly robust estimation for correcting position bias. One paper. Set up in section 7. To download these datasets and see how we the notion of query type to our user model for the code. Code is here. We discussed with Mike before where we use a simple counterfactual with some number of observed clicks. So what is loss function? Uses the richer model to estimate observation. Query type. What is query type? Rank on this observation. This paper. 3.1 of the other paper. Oh, this is amazing. This is a short paper. I love short papers. This is fantastic. You just changed my viewpoint on writing a paper. Fuck these 50 pages papers that have no, like, if your paper is 50 pages, its impact should be, if a paper we have like 10 pages, normal size of a paper, then if a paper is 50 pages, it better be 10 to the 5 more effective, not just 2 ice more effective. It's just not effective at all, actually. And this is another paper. Okay, this one I read already, so. All right, now what we need is a bit of ChatGPT. And chat, come on, chat GPT. And papers and let me get rid of all this erupt bullshit. So let's see. Elaborate experimental 7, where we want to download it. This paper, section 7. What is this one actually? Doubly robust. Section 7. Doubly robust estimation for correcting position bias in click feedback for unbiased learning to rank. From Netherlands. The Netherlands. Probability of getting a click given item at position K is alpha K. Probability of relatability given item plus beta K. So it's not, okay, that's actually interesting. It's not probability of observation times probability of observation, probability of relatability. And so trust bias. Users are more likely to click against their preferences on higher ranks because of their trust in the ranking model. Oh, this can be model. Okay, that's good. So epsilon k plus is probability of getting click given it is relatable, observed, and at position k. Epsilon k minus is probability of getting click at it's not given it's not relatable. So even if it is not relatable, you're saying it gets a probability that it's there are odds that it will be clicked on. Probability of getting observed and at position k. The proposed user model results in the following. Probability of getting clicked is at for item D at position K is probability of being observed. Oh fuck dude, epsilon K plus RD. Oh, which will be alpha K RD plus beta K. Alright. Alpha K is this and beta K is this. Alright. LTR, learning to rank goal. What is this R function? The goal of our ranking task is to maximize the probability that a user will click on something they prefer. The goal of ranking task is to maximize the probability that a user will click on something they prefer. I see. Let pi be the ranking probability. With pi kd, when the gain the probability that pi places d at position k and let y. Item D's, their model is kind of different. So it's not like we have a list of items and we are coming up with a permutation. It is item D. What is the probability of putting item D at position K? And let Y indicate a ranking of size K. Lastly, D1 to dk is this. What is Y? What do you mean we are ranking of size K? Be the collection of items to be ranked, most ranking metric. Okay, yeah. What is RYK? R pi is expectation of no. K1 to K, omega K, R. RYK. What is RYK? RD. So you're saying sigma RD sigma RD over D in the pi KD is RYK. So they assume the user model, which is this probability of alpha k, probability of alpha k RK plus we argue that our metric should actually be motivated by our user behavior assumption. I like that. This is something we want to do that as well. And then they will compute some stuff. So section 7 of this paper, alright, it has a lot of sections. It's a large paper, by the way, 34 pages. A lot of fake pages. A lot of fake pages, yes. And I won't sleep so bad. Alright, this is their experimental setup. So they have a user model in order to evaluate our novel DR. What is DR? Estimator, doubly robust estimator. We apply the semi-synthetic setup that is common in unbiased LTR. Jesus. New project. New project, exactly. Semi-synthetic setup that is common in unbiased LTR. This simulates a web search scenario by sampling queries and documents from commercial search datasets, while user interactions and rankings are simulated using probabilistic click models. We use the 3 largest publicly available LTR industry datasets: Yahoo, WebScope, MSLR, Microsoft. What is MSLR? Web30K. What was MSLR? It was a journal, right? Microsoft Learning to Rank dataset. All right, and Stella. Each dataset contains queries, pre-selected documents per query, and for the query document, so document means the item, right? They show it by D document, or because it is web search. So we have D and doubly robust. I'm feeling sleepy. So D for the document, and we have a document query pair. Feature representation and labels indicating. Okay, I think we read this one too. So then they were judged by person, but it was not on a list. Every item and query were given to a judge, and they were scaling them 0 to 4, and the queries, and then judges gave us probability of relatability, and the queries in the dataset are divided into training, validation, and test participation. test partition. Our logging policy is obtained by supervised on 1% of the training partition. Our logging policy. What is logging policy? What is O3? So O1 cannot read papers? That's fucked up. Okay. The DR estimator outperforms IPS inverse propensity scoring multiple. It requires several orders of magnitude fewer data points than IPS to achieve optimal ranking performance. It is more resistant to bias misspecification and clipping strategies than IPS. This is a big step forward in counterfactual LTR because it combines regression-based approaches while minimizing their individual. Alright, and so we labeled them. Our logging policy is obtained by supervised training on 1% of the training partition 18 at each interaction. I, a query sampled uniformly over the training and validation partition, and a corresponding ranking is sampled from the logging. Equation 1 was the top 5 setting where only 5 items have ranking. Oh, top 5 setting. Alright, basically was where only 5 items can be at once. Full ranking setting where all items are displayed. This for top 5 are based on empirical work and this. For full ranking, saying we use equation 4. What is equation 1? Okay, alpha probability of relatability plus beta. And what is equal? Dude, ChatGPT is so nice. And what is equation 4? So I think when we are doing top 5, we don't say, we say, because equation 1 is involved. And it also cares about the ranking. And cares for the ranking. For the full ranking setting, we use equation 4 with probability of observation is 1 over 1 plus k minus 1 over 5 epsilon k plus epsilon k, because this closely matches the top 5. That 5, because top 5 applicable to longer ranking with like post top 5 and I don't know where they are something like that. They are estimated with expectation maximization. All models are neural networks with 232 unit. Exception is the logging policy in the full ranking setting, which is a deterministic ranker to better match earlier work. Propensities RODI use frequentist estimates pi 0 at KD1 over N clip. So it's just telling us how they run their experiments. Expected number of clicks on preferred items. Expected number of clicks on preferred items. What does that mean? Our results evaluate our DM estimator and our DR estimator. Doubly robust and doubly both using direct method, regression-based approach. Okay, direct method. Naive estimator that ignores bias. 2. Inverse propensity score. 3. Ratio propensity scoring. What is it? And DM, direct method with L hat prime. From previous work, none of the estimator received any information about queries that were not sampled in the terrain. And display ranking top 5 setting with queries are sampled. And queries are sampled with replacement from the learning and validation for a display ranking is sample query using the stochastic logging policy. Click on trainer. Okay, this is fuck that. There is nothing. Okay, still not much information in it. What is this one? What was I supposed to do with this paper? 5 pages. 5 pages. Oh, by the way, let me give an update on 417. I think it has been definitely about more than 10 days. No day I looked at my phone and screen and it was 417. Every day I missed it. I missed 417. And okay, so let's say that None of the days I looked at the phone and it was 4:17. My alarm is at 4:20, which reminds me I missed it. Now I want to change my alarm after all these days to 4:17, or actually should I do that 4:16? So that my brain is getting trained to look at, let's do 4:17. So I am changing the alarm to 4:17, so every day I make sure I look at the phone at 4:17, and let's see if we can learn to look at the phone. Make it our subconscious, or whatever. And okay, back to the research. I'm doing research because I'm a researcher. I'm at MIT where the best research is happening. And my research is related about economics and online platforms, how they affect each other, how users' behavior is modeled on online, and their click matters to us. There is the code of some data sets that studies these behaviors, and we have some other papers we discussed. This is my paper where we use a simple counterfactual query user typing based on number of observed clicks. There is another paper. That we are saying, okay, we used 1 over log or whatever it was. Now we are saying this decay element, the ranker decay element, depends on the type of query. For different kinds of query or items, categories of items, we have different decay functions. So for example, here it says probability of observation given k is probability of 1 over k times ft, which depends on t's type of query. Alright, let's go over this paper, short paper, which is number of clicks. And the other one says it depends on the type. All right. ChatGPT is amazing in the sense that you give it a PDF and you don't need to go through the bullshit. You ask it, what is this equation? It tells you what it is. It's fantastic. Because I hate reading papers and they're so complicated to read, and ChatGPT is so good at explaining. Which one was it? Intent aware, yes. Aware. Da 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 da. Ah! It's so cold. Intent aware. Still using ChatGPT. Haven't checked DeepSeek yet, but that's great that we have multiple of them and they are in competition. It's really, I feel far safer. Intent-aware propensity model, unlike standard position bias models that assume examination depends only on rank. Oh, okay, position bias is it also depends. Can you read this motherfucker for me?
This paper, Intent-Aware Propensity Estimation via Click Pattern Stratification, introduces a new method for estimating click propensities in Learning to Rank, LTR, by incorporating user intent inferred from click patterns. Key contributions.
So they are
Intent-Aware Propensity Model, unlike standard position bias models that assume examination depends only on rank, this method stratifies click propensities based on user browsing intent, inferred from the number of clicks in a search session. Non-causal intent estimation.
So do they assume that they know what the user's intent is, or they should elicit that intent? I think they don't elicit it.
Instead of requiring query-based intent classification, it directly uses the number of clicks in a session to categorize user intent as sparse click intent, users who click on very few items.
Oh, okay, that's so
dense click intent, users who click on multiple items.
like broad query.
Regression-based expectation maximization, the model uses an M algorithm to iteratively estimate click propensities for each intent class. Better ranking generalization, empirical results show that this intent-aware propensity model improves ranking performance compared to a standard inverse propensity weighting, IPW, approach. Mathematical formulation. The standard position bias model assumes P, OD equals 1S, equals P, where ODO underscore dot is the examination probability of item DDD, and alpha caret backslash hat backslash alpha caret is the estimated click propensity at rank DDD. Proposed intent-aware propensity model. Instead of assuming click propensities depend only on rank, the new model incorporates search intent via click patterns. P, OD equals 1S, equals P, OD equals 1 rank C, S, P, O.
Instead of assuming click propensity, which is probability of, click propensity, so probability of getting click, not probability of being observed. Only on rank, the new model incorporates search intent via click pattern. So what does that? Search intent, we had like sparse or dense. So probability of observed given intent S. What is S? Where CS is the click pattern, the total number of clicks in the session. And what is S? At position S? No, because rank. Probability of CS equals 1 if total clicks is greater than D. CS equals 0 otherwise. And S is session. Probability of observing item D on session S equals probability of observation D given at rank D. So it just summarizes or simplifies or reduces the whole session to number of clicks per session. Propensity for each class are then updated using expected maximization. Alright. Experimental results, dataset 1M queries for a major e-commerce platform, eBay sample to ensure. Dude, give us these datasets, honestly. Shit, what is this? So random! Fucking random, and it is 11:11. How is that possible? It's 11:11 here too. Dense click has higher click probability. Major click top 20 results. Sample to ensure at least one click in the top 20 results. The sparse click exhibits sharper decay in a click propensity at higher ranks. The dense click class has higher click probability in low ranks. So we it has a fatter tail. The intent-aware IPW inverse propensity weighting model outperforms standard IPW in discounted cumulative gain metrics. So standard is uniform DCG, which is, what is uniform DCG? 0.8, 0.2%. Propensity adjusted DCG, what is propensity? More accurate propensity estimation, more accurate propensity estimation is better ranking and click patterns. Or user, okay, so they are using click patterns as a proxy for user intent. That's crazy, by the way. Like from an econ perspective, you say, okay, the guy has, okay, well, they are taking that click as a, what is the latent intent that click pattern is standing for? No, okay, do you get that? No user comes to the platform and says today, oh, my intent today is just clicking sparsely or densely. But they are taking that click behavior as an intent. Intent usually is a latent variable that like observation, the behavior observed comes from the latent intent, but they're taking it as. But conditioning on that click behavior helps, I agree. Combining click-based intent estimation improves general comparison with doubly robust estimation for correcting. Oh, this is extra work by ChatGPT that says, all right, I'm going to compare this paper with a regression model. All right, that's ChatGPT is amazing, and it is not actually O1 or anything. So probability of getting click, probability of being observed, probability of relatability, and relatability hat is click over probability of being observed, and IS, what is IS? Let's go equation. Can you explain? Fuck them. Yeah, fuck you all, guys. Can you explain? Fuck the fuck, get the fuck out of my face. Can you explain equation 5? Fuck you all. 5 probability of equation 5. Intent ever click propensity model which extends the standard. No, it's not this. Intent ever click propensity equal. Is it this? But no, this is this. I mean this one. Okay, yeah, maybe. Well, it's not that. C of CDS, very. I of CDS, it's not. Why do you change it? Um, am I offline? I don't want intro. Okay, so probability of O equal 1, probability of O equal 1. Dude, I can even snip it from the paper, like the equations, and put it on Chat GPT. That's amazing. That's really nice. So fucking amazing. Honestly, I'm so happy. O P by D I S, and it can read the photo. Probability of O1 given pi D pi toddy. No, it's not pi toddy. It's just pi D. OD1 user examination item equals the session pi dot the ranking position of item G. IS represents user browsing intent. C of DS is okay, so S becomes C of DS. This is the assumption they are making. Total number of clicks in the session. This equation states that the only item being examined depends on both its rank and its user position. Just find the from search session S. Total number of clicks in the key idea. So they do not elicit intent, but they just assume intent is. They just wanna make the decay depend also on the number of clicks. So depend on an observation. That's beautiful, good idea. However, it's not an. They are making it as a function of observation. I like that. Mm-hmm. Intent is something usually hidden. That's what I'm saying. Reduces bias, more accurate click propensity enables this. Alright, and let's go over equation 7 as well. So IS is ICDS, alright, discussions. Empirical research question. Let me also put this theta chi. What is theta k? Well, this is not this. I don't think you're right. 1 minus OD, is that it? It's minus CD, you're wrong. Don't be dumb. 1 pi d equals JIN. Okay, let it. That's the thing. I think next step for ChatGPT and this kind of app is just being able to read like photos, handwritten documents. Let's assume like we write down and they take it into LaTeX, beautiful writing. That would be amazing, right? So if they can convert a writing or a photo to a typed writing, that will be our LaTeX code. Then we don't need to type anymore. This is amazing. We write, give it to ChatGPT, types for us, gives to another person. Okay, it understood the photo far better than telling it, yo, go read equation 7 from the paper. Okay, read it completely right. Expectation minus minimization update rule for estimate intended work. K plus 1, T plus 1 is data Ki is the updated click propensity estimate at rank T at iteration for intent class I. But you have 2 intent class, right? And intent class 1 or because CDs are either 1 or 0 at iteration T plus 1 exactly for position K. S is the set of search sessions. Okay, DS is the documents available in session S. AI Chi if at it AI Chi is at rank K. What is my guess? At rank K, 1 if the item D is at rank K for and belongs to item class I, otherwise. Okay. Well, instead of 1 AID, you could put 1 AIK instead. Okay, AIK is pi d equals k and is equals exactly the same shit. But putting it, okay, that's the wrong thing with the notation. You don't want to put braces around AIK, just AIK is a set itself. This is a fucking paper and they have wrong notation. There is nothing wrong with bullshitting and having mistake in your paper. Actually, every paper should have some mistakes. It's the observed click indicator. If it is clicked, if it's not clicked, QT. If it is not clicked, it should be QT. What is QTOD? Is the posterior probability that item D was not examined, estimated from E step in the iteration. Okay. Fully contributes to the propensity update. If an item is clicked, CD equal 1. Unclicked items, if an item is not clicked, examine. If an item is not clear, its contribution is weighted by the probability that it's not examined. How much? QT, yes, based on observation, based on the examining expectation at time t, that it was not observed. Okay. Denominator normally by the number of currents of it. Stratifies. Stratify. It's 11:28. I say that too. It was so random, but it doesn't repeat. Or may actually repeat. I don't know. Okay, this is this paper, right? What else do we need from this paper? Fuck that, and then wow, I love ChatGPT. Honestly, I mean, if it improves, it gets like amazing. And what was the last paper we wanted to study? We didn't want to read this one. It's just something we read before in the past. Let me see what was Ehsan's comment on the last paper. It's amazing. What did I ask? Oh, Ehsan's paper, alright. So, the short paper was not assuming a richer user model that says probably does not use the richer user to shape the loss function. What is the loss function? The DCG function, right? Instead, it just uses same DCG, the same coefficients. Alright, okay. The same ranker. It just says probability of observation depends also on the intent model, sparse or dense. But now we are saying our loss function coefficients also depend on the coefficient can depend on the query type. Three point one. Let's look at 3.1 of the paper. Yeah, exactly. Those 1 over log can be used 1 plus r instead of just depending on the ranking. Those loss coefficients can they depend on the query type. Well, that's a really nice question. I really like it. Yeah, why not? Life is beautiful. Life is beautiful. Life is beautiful. Life is beautiful. We are interested in maximizing expected number of click given session, expected number of desirable engagement across all the slots and on the page with a suitably parameterized ranking policy by the model based on casual concerns that govern user browsing and engagement behaviors on search result pages. Fake pages. We can build effective likelihood models from which we can estimate the parameters of the ranking policy via maximum likelihood estimation. We instantiate this process with the simple fuck the haters. Data will instantiate this process with simple, widely adopted click model information, assuming a vanilla sequential. I hate the haters. Is hating the haters right or bad? Good or bad? Assuming a vanilla sequential browsing modeling along with the standard position dependent examination. What was about haters? I don't know. Dab on haters? No. So it says probability of getting click at position pi r is given session, and the item, list of item, just depends on the ranking, does not depend on the whole items, because we can say that, but we are making assumption to make our model simpler. Without making assumption, our models can be very actually exact, very accurate, but we cannot compute them. If I say instead of ranking, probability of click depends on all the item in the list, for sure it depends on that, but coming up with a ranking algorithm that is so complicated will be very difficult. So we need to make smart doesn't matter, simplifying assumptions, and if they turn out good, then we call them smart. Observation as rank are relatability given the session. Yeah. So this is the clue. Rank position R and D are represent the slot item prior to the item ranked in position R. The second line follows from assuming that the item is close to the place item in the slot is there. Okay, these are the explaining the assumption. And the last one falls from query independent global rank scale. Query independent. Propensity scores are context specific and can be estimated by explicit online. The examination probabilities, probability of O equal 1, also known as propensity scores, are context specific and can be estimated via explicit online intervention or like A/B testing, or from observational data by considering a simple univariate model fit on the estimated propensity as a function of rank One can build data-driven rank discount functions to estimate users' examination effort. The standard approach is to adopt vanilla log-based. We want to change this part. We want to change vanilla log-based that only depends on R and make it dependent on the user input. And the XWS rank design has generic estimates of the examination probability, empirical, count cumulative grade. So we are saying 1 over log there. Alright, I think I read all of the things Ehsan sent me to good enough. Good enough. Yeah, well enough. Well enough. Way enough. Way enough. Okay, next step is just cleaning my writings to show to Ehsan. Okay, well, I could go over the code. That's the part I'm missing. I have to go over the code. Alright. Let's take a break here. Huh? Yeah.